So thanks so much for being here again. My name is Abby. My pronouns are she, they. I'm the undergraduate recruitment specialist for the Faculty of Engineering here at Waterloo. So I'm very excited to have you all here, and we have lots of great panelists joining us tonight as well to share some information about our programs and help you start to think about which program might be the right fit for you. Before we get started officially, I want to take a moment to acknowledge the land on which Waterloo is situated. So, the University of Waterloo acknowledges that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldeman Tract, which is the land that was granted to the Six Nations, and that includes 6 miles on each side of the Grand River. Our active work towards reconciliation at the University of Waterloo takes place across our campuses through research, learning, teaching, and community building, and all of that is coordinated within the Office of Indigenous Relations. So I recognize, since this is a webinar, we might have folks joining from all over Canada, possibly all over the world as well. So I encourage you to learn more about the land that you occupy. So a few housekeeping items that I would like to go through. You can find in your Zoom toolbox, probably at the bottom of your screen, depending on which device you're joining on, a questions and answers box there. So you can click on that and submit any questions that you might have throughout the webinar there, and we will be happy to answer those. Closed captioning is also available by clicking on the CC button at the bottom of your screen. And if you do have any questions that are specific to you or we might not be able to get to during the session today, you can always email us at enginfo@uwaterloo.ca and we'd be happy to provide you with a response. So first of all, a little bit about our Faculty of Engineering at Waterloo. We are number one in Canada for our engineering program reputation. We're also number one in Canada for several of our engineering programs, according to a wide variety of sources. A few are listed here, and we're top 50 in the world for engineering. So we have very strong national recognition as well as international recognition for our engineering programs. And we're really excited to share more about what each program entails, according to which one you might be a good fit for. As far as how we do engineering at Waterloo, we're Canada's largest engineering school, so we have over 8,000 undergraduate students, over 2,000 graduate students, over 300 faculty members, and a wide assortment of alumni who are working in over 100 countries around the world. We have 15 different direct entry undergraduate programs, and co-op experience is required for graduation for all of our programs. So co-op is something that we're very well known for at Waterloo in terms of getting our students in the workplace before they've graduated and getting them that workplace experience. We also have a really big emphasis in all of our programs, which we might be talking more about throughout the webinar tonight, on hands-on collaborative education. So as I mentioned, co-op is something we're very well known for at Waterloo. 95% of co-op grads are employed 2 years after graduation, and they work in positions that are related to the skills that they acquired at Waterloo. So through co-op, our graduates have extremely high employment rates. 82% of Waterloo Co-op grads earn 60K per year 2 years after graduation, and that's compared to just 49% of all Ontario grads. So our grads are not only landing jobs after graduation, but they are earning well above the Ontario average. Again, I think in large part due to their paid co-op work experience that they get during their undergrad. And as far as what that pay looks like in their undergrad, the average co-op earnings vary between about 9,600 to 22,800 per 4-month work term in Canada. So that of course will depend on the type of job that you're doing. In your first few work terms, you might be at the lower end of that average range. As you get into your upper years, into more senior positions, you might be towards the higher end of that average range. As far as how co-op works, we have the world's largest co-op program at Waterloo. We have over 8,000 employers in more than 70 countries who look to hire Waterloo co-op students, and we have very strong co-op employment rates. So we don't place our students in co-op jobs. You do apply to jobs by building your resume, applying to jobs, attending interviews in a competitive job application process, just like you will after graduation. However, we do have a very high co-op employment rate at 97%. In engineering, you'll complete in engineering, you'll complete up to 6 co-op work terms. You need to complete 5 in order to graduate from an engineering program at Waterloo, and all of that adds up to 2 years of paid work experience. Another thing that really sets Waterloo Co-op apart is how we structure it. So we structure it very much kind of going back and forth between 4 months of studying, 4 months of working. Your exact sequencing, it might look a little bit different depending on the program that you're in. Some of our programs are what we call Stream 4 programs, and that's where you spend 4 months studying, and then your very first co-op work term is in your second term at Waterloo. Other programs are what we call Stream 8 programs. That's where you do 2 back-to-back study terms. So you do 8 months of study, and then your first co-op work term is in the summer or the spring term of your first year. So all that to say, some programs have variations. Some programs kind of have back-to-back work terms sometimes. So you can find all the details on our website, but either way, the way we structure co-op at Waterloo with up to 6 co-op work term opportunities is incredibly unique and valuable. So as I mentioned, we have 15 direct entry programs. Direct entry means that you'll apply directly to your chosen discipline and you'll start in that discipline right from first year. So we don't have any general first year engineering programs at Waterloo. You do have to apply directly to your program of choice. So that's why attending a webinar like this and getting information about which one might be the right fit for you is so important because you want to make sure that you're applying to the right program. So without further ado, I think we're going to launch into a quick overview of each of these 15 programs, and we're going to start off with architecture. So I'll hand it over to Fiona.
Hi, everyone. Thanks for joining us. My name is Fiona, and I'm the Associate Director of the undergraduate program at the School of Architecture here in Cambridge, Ontario. Architecture is the art and science of designing buildings and spaces to make sure they are not only functional, but also meaningful and inspiring. We think about how people live, work, and interact in spaces and how buildings shape our everyday lives. Architecture blends creativity, technical skill, and social awareness, and it's where design meets problem solving from small homes to massive city plans. We have an incredible community here in Cambridge. We are a small school, so everyone gets to know each other really, really well. And both within the school and within the community at large here in Cambridge, we've really kind of embedded ourselves in creating this really wonderful, very, very special place. We design buildings that are safe, that are beautiful, and they meet people's needs. We have a lot of fun considering materials, structure, light, and sustainability. We also work with teams of engineers, city planners, and construction teams to turn designs into reality. And we think about how buildings reflect culture, community, and the environment. You might be interested in architecture if you love art and you love design, you love math, physics, but you also want to solve real-world challenges through the built environment. And it's about shaping the spaces we live in responsibly. Within our curriculum, you'll learn how to draw in a range of media. You will also work in models, digital fabrication. So those of you who are interested in robotics, community engagement, design build, field trips, including a term at our campus in Rome. I hope that you'll consider joining us and that you'll please reach out if you have any questions. Thanks.
All right, so moving to architectural engineering, this is Mohammed Araji. I'm the director of the AE program, and I'll cover the next topic on architectural engineering and the following one, which is on civil. So in architectural engineering, we really look at how civil engineering meets building design, and specifically, in addition to aesthetics, we look at the building structures, building structures, building systems, and building enclosure assemblies, and how we can put this together into a safe, energy efficient building that we offer as part of the design package. So as a student, you would be interested in our program if you like architecture and design, but you also are interested in being on the technical side of how buildings really work. And it is about bridging this buildings to life from the inside out, if you think about it this way. So architectural engineers, for instance, can focus on the systems inside a building like heating, lighting, electricity, and structures, and how everything works together for comfort, safety, and sustainability. So what do we work on can vary from creating smart, sustainable buildings that use less energy and reduce emissions to maybe integrate renewable energy like solar panels into buildings, or in terms of structures, we look at how we support building structures and the variety of building materials that go into the building, from mass timber construction to steel and concrete and other forms of materials. As well, like for building systems, we look at how we can get the building function in different climates and with different boundary conditions for weather. So this is what AE is about. And one more thing I can add to this is the fact that we have a curriculum that's spread between the civil department and the architecture department. So you will get the 1 year stay in Cambridge, which is a very lovely campus as part of the study on this topic. So you will be learning as well the architecture side of doing things, and what Fiona has, for example, introduced to you, you probably will see it firsthand through students' engagement there and through a faculty who will always co-teach you in studios between architecture and civil professors. For the civil engineering, it's really about designing and building the world around us. So this goes from the roads we drive on to the clean water we drink. And engineers really use math, physics, and creativity to plan, build, and maintain the infrastructure that makes modern life possible. So if it is something that is big, can be built and benefits the society, there is probability that it's a civil engineer behind it in this case. So civil engineering is perfect for students who want to solve practical problems like the result of their work and make the lasting impact on communities. For example, how we work in this field might relate to designing the roads, the bridges, and the highways to keep people and goods moving, for example. And or if we think about the plans that we have to put for transit systems like subways and bike lanes and train lines, or if we're thinking about water, so how do we build water systems for clean drinking water and wastewater treatment and management in buildings and in the city around us. We also support sustainable cities through green infrastructure and smart planning. All of this is part of the civil program. And I think it's a great opportunity to look at the different programs in this department that we have that spans between architectural engineering, structure, and civil, in addition to the geotechnical and other topics that are covered as part of the civil program.
Hi, good afternoon, everyone. My name is Maricor Arlos, and I'm an assistant professor in civil and environmental engineering. So I'm going to talk about two programs in engineering, the geological engineering and environmental engineering. So first, the geological engineering is the kind of engineering where you work with earth. It's rocks, soil, water, and natural forces. And you would like to design safe and sustainable infrastructure as well. So geological engineers use physics, engineering, geology to understand what's happening below the surface, and also make sure that we build things like roads, tunnels, dams, and mines on solid and stable ground. So make sure that nothing will collapse or fall off the ground after being built. So it's a relatively small program with an intake of about 25 students. And most geological engineers, they work on assessing and finding natural resources like minerals, oil, and groundwater. They also study landslides, earthquakes, and sinkholes to reduce risk. They also make sure that the buildings, bridges, and pipelines are built on safe and stable ground. They help design tunnels, dams, and foundations that won't collapse or shift. I know a bunch of our geological students would have co-ops in Nunavut in mining, diamond mining industries to get the experience of being a geological engineer. So geological engineering is really perfect for people who like outdoors. It's one of the programs that has a lot of field activities and field experience and experiential learning related to the field of geological engineering. It really helps you, it really is focused on solving real world problems, also understanding how the earth works, and making sure that everything we build above the ground is safe because of what we understand below it. Next is the environmental engineering program. I am an environmental engineer. I actually completed my bachelor's, master's, and PhD here at University of Waterloo and in environmental engineering. So I'm very proud of this program. I left for 6 years and came back. I never thought I would come back here, but very, very happy that I have, and very proud of the programs that we have at Waterloo, and particularly the environmental engineering program. So our program focuses on protecting human health and the environment, and we apply many principles of science and engineering to solve problems related to air, water, soil, and waste. So a lot of the environmental engineers design systems that ensure clean water, safe air, sustainable development, really trying to minimize a lot of the pollution, manage our natural resources, and also mitigate the effects of climate change. So many of our students work on water treatment systems. So Waterloo is also one of the well-known water research institutes in the world. So there's a lot of water research experience and expertise within the department. So we have a good number of people looking at water treatment, wastewater treatment. So basically figuring out what happens to our water when we flush the toilet. You know, what happens to whatever we do at homes. They always go to a place where environmental engineers do and manage those wastes. We just don't look at water. We have expertise and folks here who look at air pollution control, stormwater and flood management as well, making sure that, again, we need to protect the public health. Places that are prone to flooding, for instance, we want to make sure that those people around the area are safe. There's a lot of students who have done co-ops in environmental assessment sites, contaminated land, and groundwater, for instance, because of legacy contamination. But there are a lot of people also looking into renewable energy integration and also carbon reduction strategies. So overall, environmental engineering does combine engineering design with environmental science. So we have a lot of our fundamentals in biology, environmental biology, chemistry, also physics. And we use those fundamentals to create systems that are safe, that are sustainable, and also efficient. So a lot of roles that address both technical challenges, and also societal challenges, but really contributing to that healthier community and more sustainable planet. So if you have any questions, feel free to reach out to me. I went through the same process as you back in 2005 when I wanted to, and I picked Waterloo. So I'm very, very happy about that choice 20 years ago now. Thank you.
Hello, so my name is Dr. Rancom. I'm a lithium-ion battery expert and a chemical engineering professor here at Waterloo. So chemical engineering is one of the OG, or the oldest engineering discipline, alongside with mechanical engineering, electrical engineering, civil engineering, and this is because of its fundamental role into this science. Chemical engineering is about leveraging chemistry to turn raw materials into useful product, but on a very large scale. So think about plants and mass production. So for instance, a chemical engineer will produce the steel that is used by the mechanical engineer, the glass, the plastics, the foams, the paint used by architects and also civil engineers, as well as refining all the copper that you find in electrical wiring. So this is very, very fundamental to everything else. And it is not limited also to basic product like steel but also it can be advanced systems like my own, which is batteries, but we also have a professor who does you look at stem cells and how to make regenerative tissue out of it. We have a very, very advanced chemical productions, basically, of materials. So you can also think about nanobots and anything that is produced through a chemical reaction. So this puts the chemical engineer into a very prime position to tackle all the global challenges that we have right now and have an actual strong effect on them. For instance, if you think about hunger, you have the mass production of food in the supermarket that we buy, and that is very, very important. So is the water treatment in big plants. So you'll see things that are overlapping a little bit with other disciplines, but that's normal. But chemical engineering, again, thinks about big plants. We are also very fundamental to sustainability, always as climate change and pollution. Pollution on both sides of the equation. For instance, since we're responsible for the production of things, we want to have production methods that are more respective of the environment, that are also requiring less amount of energy as an input. And on the other side, when you think about recycling of the materials, we have to come up with protocols to recycle these materials into new base materials that allows us to do the circular economy where we are sparing the earth a little bit. So in terms of specialization, it's very wide and depends on what you like best, basically. Some people, for instance, are very keen in computer modeling, and we need that for modeling chemical processes, understanding more how they work and how we can apply them better. Some people are better at optimization and control of plants and systems that are already in place, and they want to make work more efficiently. Energy and environmental systems. So energy, again, on both sides of the equation, you have the petroleum industry that is very important to humanity, as well as more my field, which is storage of renewable energy into batteries. And of course, materials and manufacturing processes. So you can find chemical engineer in pretty much all of the industry that you can think of, including being a professor, or in the EV industry, in the buildings and things like this. But most likely, you'll find them in one of those four career that I'm going to say right now. So the chemical production, pharmaceutical processes, clean energy, and sustainable manufacturing. Thank you.
Hello, my name is Drew Liu. I'm Associate Director of the Nanotechnology Engineering program. And Nanotechnology Engineering is a very unique program because you actually learn a lot of chemistry, biology, and physics. You need such knowledge to do engineering at the very small nano scale. So when I say nano, it really means 1 nanometer scale, right? So between 1 and 1,000 nanometer. Many materials have properties that are size dependent at such length scale, and we can use those properties to make better computer chips, make a computer run faster, make better batteries that last longer, and make drug delivery systems like vaccine that can be more powerful and safer. So essentially, right, so you have a very powerful platform to do things at the bottom. And I always think the nanotechnology engineering is a program if you are not sure what you want to do, but you want to be an engineer, right? So this maybe, give you a few more years to think about, right? Because it's a very diverse program. We have 4 specializations, including nanobiosystems, nanoelectronics, nanoapplication, and the nanomaterials. So you can see, right, it goes from bio, electronics, fabrication, and the materials. And students, right, after they graduate, they can go to industry to become an engineer, to do fabrication, manufacturing, and they can also be a biomedical engineer, develop biosensors and the drug delivery systems, and also they can also go to a microelectronics industry or as a material engineer to make advanced materials. So yeah, it's I think it's a very unique program, and you learn different things. A lot of students, they find jobs, and many students also, they go to grad school and take other pathways, including making their own company. Thank you.
Hello, my name is Douglas Harder. I'm a professor in electrical and computer engineering. I'm going to speak first about electrical engineering. This is what powers the world and connects the future. Look around you. The power that lights your home, the phone in your hand, the satellites that connect us via GPS. None of this exists without electrical engineers. This is a discipline that is about designing the systems, the electricity, the communications, and the electronics that form the backbone of this world. At Waterloo, electrical engineering is about both fundamentals, Maxwell's equations, and future impact. You will study how energy is generated, transmitted, and used. You will see how wireless signals carry information across the globe and how tiny circuits can monitor your health or control spacecraft. Just as importantly, you will put this into practice through our unique co-op program, rotating between classes and paid industry. What does that look like? Some of our students end up working designing circuits for Tesla or other automotive companies, working on next generation electric vehicles and possibly autonomous. Others help expand renewable energy systems at Hydro One or test satellite communications at the Canadian space agencies. Still others join international labs where they contribute to medical imaging devices, advanced robotics, artificial intelligence, or wireless 3G and 5G and 6G networks. What makes Waterloo stand out is scale and opportunity. By the time you graduate, you will have worked in multiple industries, earned a salary that helps pay for your school, and build a resume that looks like that of a professional's. Whether your interest is in clean energy, aerospace, telecommunications, or health technology, electrical engineering at Waterloo gives you the foundation to power what comes next. Next, computer engineering, building the future of technology. Imagine designing the core of tomorrow's technology, the systems that are inside self-driving cars, the processors behind artificial intelligence, or the secure networks that protect your banking apps. That's computer engineering. At Waterloo, you will not only learn how computers work at every level, from the electronics inside the chips all the way up to the software that runs on it, but you will also apply that knowledge right away in the real world through our co-op program. This means you will graduate with 2 years before you even get your degree, 2 years of work. Where could you work? Think of writing code at Google, or Microsoft, designing processors at Intel, or testing autonomous vehicles at automotive industries, working in artificial intelligence. Some Waterloo students even find themselves at CERN in Switzerland at the particle accelerator, creating impressive devices. And one other student has even found himself on NASA's gravity-reduced aircraft, that is the Vomit Comet, to test hardware that must perform flawlessly in space. What makes computer engineering special is the blend of hardware and software. You will not only be limited to coding apps, and you will not only be restricted to designing circuits. You will have the flexibility to move across industries, cybersecurity, artificial intelligence, robotics, medical technology, gaming, and more. And because of Waterloo's co-op program, employers know that our students, and they will know exactly what you are capable of even before graduation. Thanks.
Hi, I'm Paul Ward, the Associate Director of Software Engineering. So while Doug has talked about computer engineering as being good for hardware and software, the software engineering program focuses exclusively on software. It is unique in that it is a joint program between the Faculty of Math and the Faculty of Engineering. The software engineering students are considered to be electrical and computer engineering students, but also computer science students. They have full access to all of the computer science courses, well, modulo the ones that computer science students take. Computer science also offers programs for non-majors, which our students obviously don't take. Why would you choose software engineering? Because you are specifically focused on wanting to write the software that is changing the world. You might think software has changed the world already, and in many ways it has. The world is completely different than it was 50 years ago because of things like automated banking and, well, automated more or less everything. We're only just getting started. The AI revolution is going to change the world even further. A lot of students or potential students seem to be quite nervous. They're thinking AI is going to take their jobs. AI is not going to take the software engineering grads' jobs. The software engineering grads are going to be creating the AI solutions that will improve people's lives. It is a tool. It is a tool that the students use. I am having them use it in SE 101 this fall in a big way. It is improving everybody's life. We have some specializations within software engineering. Currently, you can specialize in AI, business, computational fine art, human-computer interaction, and we are in the process of creating an embedded software systems specialization, because there are far more computers in your car and in your fridge and in your dishwasher than there are on your desk. So if you want to write software that will change the world, software engineering is a great program to get into. Thank you.
Hi, everyone. My name is Ada Hurst. I'm one of the professors in management engineering, and it's my pleasure to tell you all about it. I think if you think about the world today, every company is flooded with data. It has so much data to use. But the real challenge is knowing how to turn that data into better decisions, better, smarter systems, real results. And that's where management engineering comes in. In our program, as a student, you will learn to basically drive data-informed decisions. What does that mean? It means using analytics, data analytics, to improve processes, the products that you design, the systems, And increasingly, in a world that is more and more digital, as we've talked about, and more data focused and more AI driven. For me, what makes the program really unique is that it blends very different areas of expertise. So we have, on the one hand, we have the technical side, the math, the data, the AI, optimization, software. And then on the other side, we have the business and the human side, business strategy, economics, how people and organizations actually work and actually make decisions. And when you put these two together, what it allows basically is for the design of solutions that are not just technically strong and technically sound and useful, but also practical and effective in the real world. And I like to think about management engineering as learning how to make these very complex systems, the ones that have both social and technical aspects to them, make them work better and smarter. In the program, the skills that you are going to build as a student are, I think, very versatile, very in demand. Our data shows that students work, whether it's on co-op or after graduating, they work in pretty much any industry, industries as diverse as software, finance, supply chain and logistics, healthcare, manufacturing. And across these very different industries, they have some very typical, what I would say, typical management engineering roles. And these roles are also very similar to what versions of these students will also do in co-op, especially in more senior co-op terms. The kinds of roles that students take on and graduates take on are those of business analysts, for example, using data to guide smarter decisions in the organization that you work for. Product managers, building technology, or what they do is they work basically interface of technology, business, and the customer needs. You could work as a consultant to help organizations transform and innovate. You could work as a data scientist or a data engineer. These are the people that build the models that power those insights, those data-driven insights that I just talked about. And then you can also work as a software developer. The program has a strong software component, and many of our students also work as software developers, basically designing and creating software solutions. And I think it basically, the industries in which the students work in and the range of careers that they do, it really shows how versatile and future ready I think the students are. So maybe I'll end with a question. If you're wondering if this program is right for you, maybe one way to think about it is if you are someone who likes to solve problems, who likes to make good decisions based on data, who likes to think about making decisions that are solid based on a lot of information, a lot of data. If you like leading teams, management engineering, I think, can be a good way for you to turn those strengths into an impactful careers. And if you have any questions about program, please don't hesitate to reach out. You can just basically Google my name, Ada Hurst, and Waterloo, and you'll be able to find my contact information. Thank you.
Hi, I'm John Zulick. I'm a professor in systems design engineering. I'm also the director of the undergrad program. So systems design is an exciting program with a rich history. And we have had this slogan that systems is how we understand the world and design is how we change it. And when we provide our students with a collection of courses that have the same math and methodology to solve a variety of systems. In today's world, today's graduating engineer will not tend to work at the same place or at the same job all the time. The world is changing quickly and the engineers have to adapt. And I think what our program provides is the capability for our students, these fundamentals, so they can adapt to a changing world and have a rich career. The program in general has 4 specializations or 4 key areas. Physical systems, for example, building robots, cars, drones, intelligent systems, which is related to the sensing and the perception. How do you create these cars and drones to function autonomously? And in our 3rd year, we're introducing a course on AI that is part of our core, as opposed to the students taking a specialization to get some AI experience. in terms of an academic program. One of the other areas, human factors, if we look at pilots, how do pilots steer a plane? How do you design the controls? Or fly by view, for drone operation. How do you design these interfaces for these operators to control the drones? The fourth area that's key in terms of our specialization and areas of focus is called socio-environmental engineering. And the best way to describe it is you can talk about systems in terms of cities, roads, waterways, but there's also other types of systems in terms of the political system, how the cities are governed. And another one is looking at the people and the quality of life. And socio-environmental is the balancing of all these three different systems and looking at how they interact and trying to determine what is a good solution along these different dimensionalities. And the other thing is that when I was mentioning these areas of specialization, we also have core courses in these areas of specializations as we go through. So you get a flavor of each of them. And like I said earlier, the ability to adapt to a changing world, I think that is what systems design engineering provides to our incoming students who want to take this program. Thank you.
Hello, my name is Maud Gorbet, and I'm a professor in the Department of System Design Engineering and the director of the Biomedical Engineering undergrad program. And so biomedical engineering is actually a very interesting discipline, and it's an expanding discipline. What you're likely, often people don't quite understand what biomedical engineering is. It's very different from biomedical science or becoming a doctor. Really, what you're going to be doing as a biomedical engineer is developing technical solution, technological solution to enhance health, the healthcare, to provide better support, to help to support the quality of life of people. And so when you're looking at this field, you can go anywhere from applying your skills to something related to medical solutions, so within an hospital, for example, but also thinking about, for example, rehabilitation. So for someone who potentially is an amputee and need a prosthesis, you're going to have to understand, some of the really important elements around the physiology and how you design something that's comfortable, that allows them to work properly. And so there's a lot of different elements that relates to understanding the physiology, but also applying engineering to those skills. So that's kind of where, if you're interested in working on solutions that are directly applied to the human, that's kind of a field where you may want to look at. Something that's really important to understand is that while you would be working with doctor or clinician or practitioner, medical practitioner, you are not a doctor. So that's a big difference from that perspective. And so you're going to learn as part of this through the program. It's important to actually be able to have the knowledge to interface with different practice and different disciplines so that you can develop those solutions. So as part of this, where would you work if you were going to become a biomedical engineer? This is a very broad field, so you can imagine it's anywhere from developing solution that can be medical imaging solution like X-rays, MRI, and all those different things, all the way to developing material that is going to be implanted in the body, or a product where basically you're going to be looking at images and AI is going to help a clinician determine if there's a tumor on a slide that they're looking at. And so you can see it's a very broad field. And so what happened is, how do we teach you to actually work in that environment? Is that it's a very interdisciplinary program. You're going to be learning some biology, some physiology, some physics. So natural science is really important. You're going to be taught different engineering tools, thinking about, how do you measure signals and what do you do with them so that you can develop something that will measure it and then actuate for example, prosthesis. Thinking about, as part of what I mentioned earlier, is that because you're going to be working with different stakeholders like doctors and the user who is going to potentially wear a prosthesis, or you're also going to need to be working in the regulatory environment because many of those devices are regulated, then design is going to help you understand all those different elements. And so there's a lot around, understanding the perspective of your stakeholders, understanding what the regulations are, and with the tool that you have and the knowledge that you have in science, you can then develop those skills to apply them in the medical field. The program is a collaborative program, and we work with the Mechanical and Mechatronics Engineering Department, Chemical Engineering, Electrical and Computer Engineering, as well as the School of Anatomy and the Department of Biology. Because again, one of the big elements of becoming a biomedical engineer is that interdisciplinary element that you need to be able to navigate and discuss your technology and make sure that it's actually working and people can use it in a way that is valuable for them. And so, if you're interested in developing solutions that can improve people's life and that also can improve healthcare system, this program is likely something that you want to look a little bit more of. We have 5 specialization: biomaterials and tissues, so that's much more related to developing materials to be implanted in the body. Medical artificial intelligence relates to developing systems that can help with analyzing health data. Medical device relates to looking at how you develop different type of implants, for example, or also looking at medical imaging technology. Neural engineering is looking at, how do you study the study of the brain, basically looking from either a signal processing that can occur, but also thinking more from the brain-computer interface. Like I'm sure a lot of you have heard about Neuralink, and so that's really where that neural engineering piece comes into play. And finally, sports engineering relates to developing technology that can improve or prevent injuries while playing sport, but also allow for safer and more effective training. And so on that note, I will I think it's mechanical engineering after me. Thank you.
Hi, everybody. My name is John Magliaro. I'm a new-ish professor here in the MME, that's Mechanical and Mechatronics Engineering Department. So first off, thank you for hanging on this long. I'm sure we're getting a little fatigued, but I'll try to make this as digestible as possible. So one of the main goals I want to take, or at least give you as a takeaway, because it's definitely the most common question we get, is simply what is the difference between these two M's? So mechanical engineering, which for the record, that's sort of where my expertise and interests lie. It's the older of the two kind of sub branches. So mechanical engineering stemming all the way back to those 6 classical machines, which if you haven't heard of them, right, the pulley, the lever and fulcrum and so forth. So that's evolved with us, so to speak, into just this huge discipline. So it's certainly a long 4 to 5 years to get your degree, but we're jamming thousands of years of progress in there. That might sound like a cliche, but that's really how it is. And the main takeaway with mechanical engineering, and it's overwhelming because it's so broad now, is that ultimately it's applied physics and tied to the study of motion, moving systems. So in general, the tongue-in-cheek explanation I've always heard is that in civil, if things are moving, as a general rule, that's really bad. In mechanical, if things are not moving, that's not so good. So it could be anything from vehicle systems, right? That's classic bread and butter mechanical engineering. So that could be the axle, the drivetrain, could be even the fluid power systems, the cooling systems and et cetera that are in that vehicle. I'm picking on vehicles. You can tell I'm from an auto heavy community. So maybe that's where a lot of it's coming from. But in any case, right, anything that's moving, and it's exploded because as manufacturing has advanced and as all these control systems have gotten smaller and smaller, it's become easier to make moving components. So automation's become a big part of what we do. fluids at multiple scales, not just great big things like hydraulic cylinders. So if you're someone who's really interested, like I said, in big macro scale moving systems, or if your interests lie, let's say, again, really hardcore into the applied physics, like metallurgy, like power systems, it could be anything from in the energy sector, right? Anywhere along that pipeline, product design, right? I mean, we're finding more and more of you as you come in are familiar with CAD/CAM. We hardly have to teach it to you anymore. That's firmly where you fall in mechanical engineering. And I don't want to go on and on, but the jobs are equally as diverse, because the world around us is becoming more and more interdisciplinary. You don't just need mechanical engineers on every project period, but you need mechanical engineers that come in those different flavors. Becomes more clear, honestly, as you go through the program. There's really no other way to find your niche. It tends to find you instead. But again, it could be on the solid sides of things. It could be materials and metallurgy. It could be fluid power systems, right? Anything from liquid to gas and so forth. But now I'll move into mechatronics engineering. So that second M in MME. So it gets a separate slide, and when they started the program, because I believe we had the first, if not the first, one of the first in Canada at Waterloo, and the thinking was that we would sort of foster them in mechanical, and then mechatronics would eventually go off and become its own discipline. But they've stayed with us, and I think that's a good thing because mechanical and mechatronics are deeply married together. They're so broad on their own now that you tend to need experts in both. So if mechanical engineers are the ones doing the more hardcore fundamental physics groundwork, the mechatronics team takes that system that's able to move and adds intelligence or sort of brings it to life. That might sound cliche, but that's ultimately how it works. So you can think of it as you need a hardcore hardware level electrical engineer to design the GPU, right? To design the CPU and so forth. You need a software engineer to turn that computer into something that doesn't just blink and light up. So hopefully that's not too clumsy of an analogy, but that's ultimately how mechanical and mechatronics work. So mechatronics is certainly a newer field. I would say you could pinpoint its birth, give or take, or at least really the inflection point around World War II, and especially post-World War II. Guidance systems, radar, positioning, targeting, and so forth, right? Finally, we had the means to do it. We definitely had a vested need through World War II to be able to do it. And then, like many things, the technology carries on in peacetime. And so now you're seeing fields like, again, because electronics are becoming so miniature, right? Um, Even your dishwasher, right, technically is an automated system. Your fridge, right, even has autonomy now. So autonomous vehicles are certainly that big one too, that it feels like we're on the cusp of. But the takeaway I would say is that um, these two programs ultimately are two sides of the same coin. So if you're someone who wants to be lower level, more fundamental, what are the components? How do they fit together? So forth. I would say you fit in the mechanical camp. If you want to take that moving system and figure out how it should be moving, right? How it interacts with the world. So feedback control, things like that. And certainly if you have that sort of, if you have that knack for software, then you fall more into the mechatronics camp. But I would hasten to say that because people always worry, is one better than the other? And again, I'm saying this as someone who is firmly that first down, mechanical. You will be qualified to do both if you take our program. So you are not closing any doors to you by choosing one or the other. It's purely about where you feel your interests lie. But ultimately, doing either program, you're a problem solver, and you could do them in either camp. So I'll close it off there. Thank you for hanging in this long.
All right, thank you so much to all of our faculty members for those overviews of those programs. I think that's a great note to kind of wrap everything up as far as the program overviews go. We have a few minutes left, and I'm just going to talk a little bit about applying to our programs, as well as what your next steps will look like. So first of all, when you apply, you'll apply in the Ontario University Application Centre, the OUAC, and you can indicate only one Waterloo Engineering program on your OUAC form. So you can only apply to one of those 15 programs, well, one of those 14 engineering programs, and you could actually apply to one of our 14 engineering programs as well as architecture. Architecture is very different in a lot of ways to our 14 engineering programs. So you'll see a lot of exceptions like that in the admissions process, but all that to say, you can only indicate one of our 14 Waterloo engineering programs. So you have to choose chemical engineering or management engineering or software engineering, etc. After you submit your form on the OUAC, you'll get a follow-up email from us to log into your applicant portal, and on there you're going to see the engineering alternate form, and that's where you can indicate an alternate program choice. So if there is another engineering program that you would want to be considered for, if you weren't to be admitted to the program that you applied to on the OUAC, you can let us know via that form. But please do note that biomedical and software engineering are not available as alternate program choices, so you would have to apply to those programs directly on the OUAC. Like I mentioned, you can apply to an engineering program and architecture as two separate choices on your OUAC form, and it's very important to note that transferring from one engineering program to another is very difficult at Waterloo Engineering, and it's not always possible. So that is why it's important now to do your research into our programs and find the one that's going to be the right fit for you so you can feel confident when you're applying. Another thing that's important to take into account in the admissions process is the competitiveness of our programs. So this is our admission averages chart. It gives you an idea of what a minimum competitive average is in each of our engineering programs. So you'll see quite the range here. Software engineering is our most competitive engineering program, and a competitive average for that program is in the low to mid 90s. But depending on the program that you're interested in, a competitive average might be in the mid to high 80s. So competitiveness very much differs depending on which program you're looking at. So definitely that's something to take into account when you're considering our programs. The middle column there, student intake, refers to the number of students that we hope to have sitting in our classrooms for first year in September. So this is not the number of students that we give offers to, but it's the number of students that we hope that we'll have in our first year classes. So that also gives you a sense of the size of your cohort in each program. As far as selecting that alternate engineering program, do consider the expected competitiveness of the applicant pool. So software engineering and biomedical engineering are very competitive programs, which is why they can't be selected as alternate program choices. Ultimately, a good alternate program choice is one that's in a less competitive applicant pool compared to the one that you apply to on the OUAC. Only choose an alternate engineering program if you're genuinely interested in studying in that program, though. If you don't have any interest in studying that program, you don't have to fill out the engineering alternate form. Definitely don't accept an offer to an alternate engineering program if you're not going to be happy in that program, because like I said, it's very difficult to switch between programs, so we don't want you coming to Waterloo with the plan of switching programs. And ultimately, our goal is to admit as many applicants as possible to the programs that they wish to study. So we definitely prioritize students who apply directly to an engineering program on the UAC, as opposed to those who choose it as an alternate choice. Ultimately, when it comes to selecting your program, we recommend that you stay true to yourself, select a program that's based on your interests. Oftentimes students will regret choosing a program for other reasons, so definitely think about what you are most interested in and apply to that program. Keep in mind that while the opinions of family and friends are important, you're the one that's going to have to spend 5 years studying in what is quite a rigorous engineering program, and so it's really important so that you succeed in your program, that you're passionate about it. You need to be self-motivated to successfully complete a program. And if you don't enjoy your studies, you're going to find it really difficult to manage your time and your workloads. So all of that to say, at the end of the day, it's about where your interests, your values really align and which program that aligns with. So just a few events that I wanted to highlight that are coming up where you can continue to learn more about our programs as well as the admissions process and anything else that you might be wondering about. This upcoming weekend is the Ontario University's Fair. That's at the Metro Toronto Convention Centre in Toronto. We will be there. We'd be happy to meet you and talk with you. We'll be hosting a variety of other webinars, so some of these you may already be registered for because you've signed up for them. when you registered for this webinar, but there are some webinars that are happening through our central team that are just generally about Waterloo. So those are like applying to Waterloo, co-op at Waterloo, and they'll also be doing an application info session right before our application deadline in January. So if you haven't registered for those and you'd be interested in those in addition to our engineering specific ones, definitely check those out on our website. Otherwise, though, we'll be doing our tips for applying to Waterloo Engineering webinar near the end of October, and then a series of engineering student stories where we'll really dive a little bit deeper into each of these programs. So if you're still not sure, definitely check those out. And highlighted here is our fall open house happening on Saturday, November 8th. If you are able to come to campus, that is one of the best ways to get a sense of what we're all about, and you'll be able to talk to faculty, staff, current students, lots of ways to learn more at Fall Open House. So if you're able to make it, we definitely encourage you to do so. These are just a few other resources that you can check out. Definitely reviewing our program pages on our website. If you're really not sure where to start, we do have an engineering program compatibility quiz, which can be a good starting point to get an idea of how your interests and skills align with our programs, and then from there doing more research and seeing which ones kind of appeal to you. You can also compare course requirements and electives by looking at our academic calendar. So if you're really debating between two different programs, that can be a good way to get a sense of the differences between them. You can chat with our current students. You can shadow a current student for a day. So if you're able to come to campus, that's a really great opportunity. And then of course you can book tours of our campus and our faculty in person, but also virtually if you're not able to make it to campus. Thank you so much for attending this webinar. I know it was a lot of information. We will be sending out the recording after in a few days, so definitely feel free to review that. If you do have any questions that we weren't able to get to or things that come up as you're kind of going through the application process, you can email us. enginfo@uwaterloo.ca goes to our engineering admissions team. arcinfo@uwaterloo.ca will go to our architecture recruitment and admissions team. So if you are interested in architecture, like I said, they're very different compared to our 14 engineering programs, so I'd recommend reaching out directly to them. Otherwise, if you're not sure who to ask, feel free to email either of us and we'd be happy to forward you to the right person. So thank you so much again, everyone, for attending, and thank you to our faculty members for presenting, and have a great night.